Okay, welcome to section 2 of the Unit 5 learning activity on dimensional reduction with principal component analysis. So we're going to be looking here at the breast cancer data. And if you remember that data from a previous unit, it looks at breast cancer tumors and does 30 different measurements of features on these tumors. So we're going to see if principal components analysis, PCA, can be used to reduce this number of features from 30 down to maybe 5 or 3 or even 1. As before, we're going to try to structure this as a kind of a scientific experiment. So we're going to ask, our hypothesis, I guess I should say, is that the number of PCI, or as the number of PCI components decrease, the accuracy of a model trained with these components also decreases. So there's a trade-off. Although reducing the number of components will help decrease the data we need, it will also lose some accuracy. Now, with this data set, it's not a very large data set, so we really don't need to do PCA on this. We could easily train, and we did previously, the whole system with 30 on the 30 features. But we're doing this to kind of illustrate a point because when we have very large data sets, often we have to use PCA to scale these down. For example, maybe you're doing a data set with movie reviews, and every user in your system is providing reviews on lots of different movies. So on a movie, you might have 10,000 people providing you reviews on that movie. So you'll have 10,000 different features or scores for a movie. Now 10,000 features are just way too many to train some of these like a sport vector machine on. And so you'd need to do something like PCA on these 10,000 features to try to bring it down to a manageable size. Often in machine learning systems with large data sets, we can't even load these all into these sorts of systems, and so we need to use PCA to reduce the data set, the storage requirements needed, and then the memory to run some of these models. So that's what we're kind of experimenting with now, is how does the accuracy of models trained with PCA work? So how are we going to set this up? So we're going to look at the original data with 30 different tumor features, and then we're going to use PCA to reduce those 30 features down to a number of different components. And then once we get that those components set up, we're going to check the accuracy of a sport vector machine trained on that data and see how accurate it is. So initially we're going to try 1 component, 3 components, and 5 components. So again, let's look at a little picture of this. We start with our original cancer database, and we're going to again break it into an X and a Y component. So the Y is our output, and that's our cancer diagnosis. And the other features, there are 30 features here. I don't have them all labeled. There's 30 features here. We're just going to call that with the variable X cancer. So X is our input and Y is our output. Now we're going to train 3 different PCA systems. One is going to try to break this 30 features down into 5 components. So instead of having 30 variables or 30 number columns, we're just going to have 5. We're going to train another system to take that 30 and break it down into just 3 components. And finally, we're going to train one to try to take all that and decrease it only into 1 component. So we're going to store these resulting data sets here. So I'm going to go back up here and look at our steps here. So first we're going to read in our data. We did that there. And we're going to set up the X and Y, X cancer and Y cancer. And then we're going to train again the 3 PCA systems. And we're going to store these results in X cancer PCA 1, X cancer PCA 3, and X cancer PCA 5. So these are our new data sets here. And then we're going to do support vector machines. Oh, let me see if I can update. By the time you get this, this should say support vector machine model 1 and 2 and 3. Let me see if I can reset that. Okay, I had to reload the page to get the updates here. Okay, so we have 3 support vector machines here, model 1, model 3, and model 5 that we'll train with this data. And then we'll compare the accuracy of these 3 models. here on this data set and see how well each performs if they're just looking at one principal component or three principal components or five principal components here. So let's see, let me expand this and let's start walking through this. Okay, step one is to read the data, and I've got this out here in this file. It's a kind of a separated value file, so I'm going to read that in. Do some indexing, and then here again our head displays the first 5 entries here. So these are the patient IDs. This is the diagnosis, either malignant or benign, and then again these are the 30 different measurements here. Now, since we're looking at these, one thing I'll point out is that there's a lot of differentiation between the size of these. Some of these numbers are really large, like 1,000, and some of them are very small, like 0.1. Here. So what we're going to do, we'll see that how we handle that next. So step 2 is to break this up into our variables X cancer and Y cancer. And again, the Y cancer is just the diagnosis page, and then the X one is the 31 fields. And here I'm using this iLoc to grab just certain fields. I don't know if you remember back when we were looking at pandas and how we grab columns out of a panda database, but again, we're just doing that here to grab those for the X cancer and Y cancer. And now if you remember, I said that there's a lot of difference in size here, so we're going to do what's called scaling. We're going to scale all these features here and look at that. Okay, so scaling is going to transform this data here so it's more uniform. I added this printout to do again the top 5 rows again here. Scaling actually converts this into what is called a NumPy array, so I have to convert it back to display the head, but that's not that important. So just this scalar.fit is what we call standard scaling. Now you'll see a lot of the numbers are in the same ballpark here. None of them are in the thousands, and none of them are really small. Again, they tend to range from maybe -1 or 2 up to +1, 2, 3, 4, that sort of stuff. They're in the same range. And I'm not going to go over the details of how this scalar works. We'll actually look more at scalars later on, but that's what we're doing with this data. It just helps with PCA sometimes to do this scaling. Okay, so now step 3 is going to be to apply the principal component analysis. And just like before, we import a library, and then we are going to do 3 different PCA systems. And remember, when we create a PCA system, we just say PCA, and then there's one parameter in parentheses, the number of components, and we can set that equal to 1 or 3 or 5. So we're going to actually create 3 different PCA systems. The first one is 1 component. The second one is 3 components. So this one with 3 components we'll call PCA 3. And the the next one is 5 components, and we'll call PCA 5. So once we get that, we're going to actually transform our data. So we're going to take our data here. Let's go back up to our picture here. Okay, so we have this X cancer data. Now we have these 3 PCA components, and now we're going to use, we'll use PCA 3 to take the X cancer data, break it down to just 3 components, and display it here, or save it in this variable. So going back here. So here we're using our PCA3 system that we just set up, and we're fitting it to the data and transforming the data, and then this is our result. And we're saving the new data set in this variable here. So to kind of demonstrate that we are actually converting this set. So this was our data set before. Again, we had 30 components here that we were working with. And now we've done PCA. So like PCA 3, we said convert this down to 3 components. So let's just do display the head of that. And again, PCA, this converts it to a different data type called a NumPy array. So I have to just convert it back to a data frame before I can do head here. But again, this just prints it out. It's not that important. And here we see now there are only 3 columns where there were 30 columns, 1 for each feature. We've condensed those down into 3 columns for PCA 3. And again, if we looked at PCA 5, it would be 5 columns. PCA 1 would actually be just 1 column. So again, this is what we call dimensional reduction. We're reducing 30 dimensions down to, in this case, 3 dimensions or 5 dimensions or just 1 dimension here. Now, sometimes when we do machine learning, we're going to break our data into training data and testing data before we evaluate it. We already have these multiple data sets and stuff here, so I'm not going to do that. I'm going to try to keep this separate, simplified. So we're not going to worry about it. And in this case, in this experiment, I've actually done this all. And it doesn't make that much difference. So I've just decided to eliminate that. So let's go on to step 4 here. So we're going to train our support vector machines. Remember in the previous unit we looked at support vector machines. There are different kinds of kernels and there's different parameters for C we can do. We're just always going to use the same. We're always going to use linear kernels with C of 1 here. And we're going to train 3 different models here. So the first model here we're going to train on X cancer PCA1. The next model we're going to train on X cancer PCA3, and the last one we're going to train on X cancer PCA5. Now we're also going to train one on the entire X cancer, all 30 data elements. And then once we train them, we'll score those on this, and then we'll print out the results. So like here, the score when we're using just 3 principal components. So rather than looking at 30 different variables, now we're just looking at 3. We get 96% accuracy on determining if this is a benign or malignant cancer tumor. Where if we looked at the entire data set and analyzed everything, it's 99% accuracy. Okay, so now we're going to go up to the write-up. So similar to the first write-up here, for the second one I wanted to write a couple paragraphs describing this experiment, kind of restate in writing. This is part of this course is to work on your writing skills. So this will be a good practice on some of that. Restate the hypothesis and the information that's in this experiment. Describe the testing process, again, in a paragraph form rather than just bullet items. Describe this here. And then include your recommendation. So we have you can see the results for 1, 3, and 5 PCA components, and with no PCA components, what is your recommendation? What should be used? And you could actually, if you want, if you want to try different ones, you can certainly duplicate this. Go up here where we did like a PCA 5, you could create a PCA 10 or PCA 2 or whatever, and then train a system with that if you want. So feel free if you want to try out something that's certainly within the scope of this. But then you want to write up this paragraph stuff. So try to get these paragraphs set up and describing basically what we've been discussing here. Good luck.